In the previous video, we have seen how to create Azure components. Let's say workspace, compute, data, how to load the data set, how to create, let's say, Kubernetes, and also a container registry. Now, if you already did this, make sure that you have to, let's say, remove it, or if you, because the cost it will be high. And now the next step is how to train our code, let's see, in the cloud. So I have also shown you last video in how to add a sub module, let's see, in our code. For instance, this AnomaVision, I have added this as a sub module. So the latest version of the AnomaVision, it will be directly here, so accessible here. Now, before indeed doing this in the cloud, we would like to make sure that everything run perfectly here in our local machine. So instead of, let's say, because training it takes much time, not much time, but I would say making these resources and doing this training, and if you have an error, you will do it again, and this will cost you, let's see, somehow money. So we can do this step previously in our local machine, which cost us, I would say, nothing. And when we see that everything is running perfectly, we can run, let's say, do the training uh, on the cloud. So as you can see here, this is our training, and this is the normal training as I have done it, as we have it in the Anoma Fusion here. For instance, we have here training. Let's see, train, yeah, for instance, stream file here, but it's somehow a little bit different from this. And as you can see here, it's just here a short file, but in our training that will be run on the cloud. It's somehow much, let's say, bigger. Why is that? Because I'm using here MLflow. This will track our, let's see, experiments, and see, create, let's see, models, create the environment, create, I mean, tracking the result, and the parameters, and everything will be tracked. And this is, let's see, one benefit of the MLflow. So now if you have any bug or any error, you can go to the version you have, let's see, you got the error, and let's see, fix this error, and it also give you a reproducible result. And now you can see here I have imported this from, not from our anomaly flip, AnomaVision, but here, because I added as a sub module, so now I need to import this stuff inside this. So as you can, but the let's see the disadvantage of this. I couldn't see it as a disadvantage, but it might be maybe for you, because we have a lot of files here in this area here. So sometimes we only need specific files from the Git repositories, but this is the case of the module. But if you would like, you can use a Git tree graph. And also would like to track, I mean, convert the ONNX into the MLflow, and it will be tracked as well. And you can see here I have some parameters, data path, and let's see, a model data path that will be saved in. And what is the data path here? So it's here in a locally, it will be as a directory to the images that I would like. But when we run this in the cloud, we have to use a file, let's see, called let me just see, where's this file? It's in pipelines, maybe job, yeah. So this, we will have our model, let's say our file. It will be trained on on the cloud, and you can see here data path. It has an input directory, and inputs, we can see it here. You can see data's path type is a folder, and here we have our data set. So that we have already uploaded from the previous. Sorry, someone is clicking the door. Okay, and let's back to this here. And maybe one question. So I would like to track, or let's say look our parameters and models. So because we wanted to let's say monitor what's happening during the training, evaluation, and also debugging, and see what's going on. Let's see if there's some any issue. This will help you to catch where's the error exactly. And these are the parameters, and as I said, these parameters will be taken in our cloud from this file here, and you can see sometimes it's somehow there are some let's say default stuff, and here for instance the default one is ONNX, and the data set we have we have also to use a data set, uh, and also for the compute we have to identify what's the compute. Also I think with the environment, yeah. So also this environment, it will be changed based on what we have already defined in our YAML file. I mean, last time, for instance, here you can see, I think it's end of the file. Yeah, this one here, for instance, it will create name MLOps AnomaVision. It should be indeed env, but yeah, this will be fixed in the next run. And yes, so also I need to evaluate the model. So why we need to evaluate the model? So I have all upload the whole data set with the training, testing, and evaluation. I mean the whole data set for only one let's see class, which is battle. And uh, here I'm trying to let's say training the model, and I have the model, the output models as ONNX or maybe as MLflow uh, files. And now I would like to see if the model is working perfectly. So I have to evaluate the data, the model on the data already uploaded, and I will show the result. Let's see as a in a dashboard that show me what is the accuracy, what is the uh, let's say the running time even for the training and for the evaluation, and every parameters it's let's see needed. And you can see here I have this evaluation. Of course you can also add it see it in the eval here, and also I have the score. This will be everything will be logged in the metrics, and this metrics will be returning to the main function. Let's see. Let me just check if it's the main function, because evaluate, and we will see it will be returning to here. And see how many values we are tracking. Say for instance backbone, batch size, index, layer indices, feature let's see dimension, and these parameters are related to the PaDiM algorithm. And here also I'm saving the version of the torch, the CUDA, if it's available or not, and everything will be here tracked. And here I'm not saving this because the PyTorch model, it's a big, let's see, file. So I'm just exporting it to ONNX, then track this ONNX file. And you can see here the model information. These are the model information, and here the input shape is this is, let's say, the default training of the even of the publication. So that's I have just save it as it is, and the created at, it will just give you the current time. And here let's see, we need to run this. So Python, let's see, it's in a source train, I think train. So this will take somehow maybe minutes. So let me pause the video and let me just show you what are the results will be. And you see here, once training is done, we convert the model to ONNX, which is indeed perfect for deployment across platforms. You can run it in let's see, any environment. And then we look this into the MLflow and its versioning and give it as a versions. As you can see here, I have a version created automatically when you run. So now if I run it next time, it will give this version as 3. It's accumulated. And also if the evaluation is enabled, it's because it's a parameterized, you can see here. And if it's enabled, we run it and look all the matrices, and we also look some JSON metadata about the model. Also, it's let's see, it help us to understand what was trained and how. And let me now just see what are the data will be saved here. So MLflow UI. And now I need to open this link. So you can see here, this is our runs. And you can see here I have 2 runs. And if I click, this is the models. And if I click, let's see which one is this one here. And you can see the parameters of the models. I have used resonant 18, number of, batch size is 2, and CUDA available, no, it's false. And this is the data path, and you can see device, CPU, and etc. And here's the accuracy of the evaluation. You can see here model matrices. You can see the training time in seconds, and also system matrices. Let's see the artifacts. So this is the, let's say, the interesting for ourselves. Let's see here the model. It's ONNX model, and this is generated by, everything is generated by MLflow. And you can see here, for instance, what are the important packages that we would like to run. So if you now use this and just install this here, for instance, in your site, it will work without any issues. And this is the requirement. It's indeed created as a requirement text file and also Anaconda. And why I'm doing this? Because if we understand correctly what is the training and do the training locally on our PC, this will save you much time. So if you just run it on the cloud and you have issues, you will be back, retrain the model. And also because for me it's also let's see, costly. So I just need to make sure that everything is running locally, and after that I will try to do it on the cloud. And this is the file that I will use when I, not this one with the job training, yes. So this is the file that I would like to use when I need to train the model on the cloud. And I think that's it. And if you have any question, just drop it down in the comment below. Thanks for watching and see you next time.